Rolling. Action. Hello, my name is Yuri Velas-Boas. I'm a cryptologist with 5 years experience with R&D in information security. I'm author of the SRVB Crypto Systems as my master's degree, and I have 4.5 years with experience in the sector with design and verification of security protocols. Right, now I'm demonstrating now what I'm calling tacit knowledge-based authentication and use of it to resist coercion. Yes, physical coercion. So I'll be introducing Great Wall protocol. That's a way for you to resist a physical threat with cryptology. So one component of it, here you have the diagram. I explain at length why this is an important thing, why we should not rely on obscurity, because obscurity can backfire. Okay, if the adversary knows your method, he may kill you just to prevent you abort your time lock transaction on Bitcoin. Okay, and my solution for it, okay, let the protocol not be obscure. Let you be unable to cooperate with your adversary, because the knowledge you use to authenticate yourself is tacit. Okay, and I will be demonstrating that I am able to retrieve that with tacit knowledge, and that will be correct to the last bit of the last pixel. The first component of the idea, however, is no novelty. Okay, I will be using memory hard hashes as a way to time lock puzzle, right? So I impose an arbitrary amount of time that is inescapable, right? This is no novelty. Okay, this exists already, right? So if I'm able to impose 1 second, 2 seconds, 4 seconds, if I enter a parameter large enough, I'll be able to impose 1 hour, 1 day, a week, etc. So depending on how resourceful the adversary you want to defeat, we impose a larger parameter here, right? The catch is what happens after you are released from coercion, because your adversary is not able to keep you indefinitely under coercion, right? What happens after, right? The answer for it cannot be, I use an obscure key, because again, as we saw, please, I argue that in detail here in this executive summary, right? You found it here, right? Here and here, like that. The answer for it cannot be, I use an obscure key, because as I argue here, that leads to perverse incentives and catastrophic failure of the protocol, right? You are incentivizing the adversary to assassinate you as a valid strategy, a viable strategy to keep you from aborting the coercion transaction. Now, here I have that GW code, as I'm calling it, right? Here it is. This is the picture here. Now, what I'm doing is, of course, to demonstrate if I change 1 bit of 1 pixel, let us pick this at random, okay? You pick this, and then go for the color. And then let us update this by just 1 tiny bit, okay? Cannot even spot the difference, right? So I'll be saving it as GW code tempered. Like that, save. Okay, and now we compare the cryptographic hashes of them. Like that. Okay, for the first one. And it will be completely different of the second one, right? Right? Okay, as expected. Now, I'll be proving to you I'll be able to recover this with bit precision. Let us do this. Now, this is a fractal renderer, okay? Fractal now. The point about fractals is there are many properties that are of interest to us, right? They have abstract shapes here that are very hard to describe apart. They are self-repetitive, meaning that if you take a wrong reference point, like, if you mistake those 2 reference points, the following, reference points from each, they are still compatible, they are still similar, right? So it's a perfect logarithm in a summary, right? It's a virtual algorithm. It's as if you have this algorithm having one key at every dead end, and yes, it's an astronomical number of dead ends, right? And you have to have the correct dead end to have the correct key, right? If you run the algorithm exactly correctly, except by one reference point, you mistake the key. And by mistaking the key, you don't have the correct result. You see the point? The idea is you have that initial state of the algorithm. Right now it's a toy example, and therefore a silly sequence, right? But if you have that state be in fact be pseudo random, and in fact a result of the time lock puzzle, a result of the memory hard hash that takes a very long time to be derived, it will mean that's the only way for our adversary to extract the final result from you, meaning this. The only way from the adversary to extract it from you, okay, is to wait for the entire time. Killing you will not solve anything for him. Threatening you, killing you will not change how tacit the knowledge is. This is the point, right? So again, let us recover our mock initial state, okay? That in this case, of course, is a silly sequence, but in the real case will not be. Okay, now. So I will navigate that algorithm, and I prove to you that I'm able to retrieve that state with bit precision. Okay, good. Then I zoom in here, and then I take that, and then I zoom more and more, as if I was roaming an algorithm, an actual algorithm, as it is a algorithm, right? Okay, I will see those two things here and here, those two inverted parentheses. Now zoom in here, and then I zoom in here, I think, yes, I check if it's correct, and it is, and then I take this sort, and then this other reddish sort here. Good. Now, you see, imagine myself having to describe what I'm doing. It's confusing. The reference points here are all self-similar, right? How am I able to describe apart all those very similar reference points, right? I have to verbalize slight nuances of angle, of color, of shape, right? Those are all similar things, yet they are, easy enough to tell apart, visually, that I can tell apart to myself. But then again, this is a tacit knowledge, a knowledge that is hard to describe here, right? Tacit knowledge. Tacit knowledge here from Wikipedia. Knowledge that is difficult to transfer. Right? Good. Now back to the renderer here. Okay, so I zoom in here, and then I find these four sorts here, and then I zoom in the very center here, and finally I am almost there, and I got here. You see the point? Finally. Now what I'm doing is I will be truncating those coordinates. First zoom, almost there. Okay, it was already almost there already, right? Now I will take those right and lower sides as reference points, and then I will be truncating the x and y coordinates, right? And the truncation will be proportional to the zoom, as it could not be different, right? Okay, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, good. Truncating like that. And here, because of course otherwise I could err by half a pixel if you get it right. And of course if I err by a few pixels, it will be a completely different hash, which we do not want, right? Because our keys depend on that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and truncating. Now, if everything goes right, and I'll be rendering this like that, and I call it attempt 1. Let us see that on Paint, and then I will zoom in. I'll be zooming out. Okay, Now the resulting metadata there, the resulting picture should appear here at any moment. There it is now. To see. Okay. Seems promising, right? No different, right? Okay. Now, opening it at Paint, because I have to introduce metadata. Okay, it has slightly less size, slightly lower size, like that, you see. Because there are some metadata missing that I will then solve by opening it on Paint. And then saving without doing anything, okay? So opening it, open it. Again, very promising, right? Doesn't see any difference. Now, Ctrl-Shift-S, and then saving like that, the very same, save. Now you saw that I didn't do anything, right? And I already have slightly more, the same size, right? I recovered the same size. Now, I go back here and I will then take the hash, and as promised, voila, the very same as the original. The original here, the recovered thing here. So you see what I did. I'm not able, I don't have the words to describe what I did because it's confusing. All the reference points are weird, are hard to draw. They are very much self-similar. They have slight nuances of color and shape, right? The positioning is slightly different by angle and positioning, right? I am not able to go tell that this is different than like I don't know, this one by what amount, because how further apart that is from that, all I did is very hard to describe. It's hard to describe what I did, right? And yet it's very easy to eventually get used to do that procedurally, right? I'm doing a procedural memory thing here, just like riding a bike, or I don't know, rolling a logarithm even, right? Playing an instrument, or playing speedrunning a game, or you tell it, right? You name it. So it's something that you can learn to do, but you cannot learn to describe. You cannot learn to describe what you do here. You see? And again, and then the blue ones here. Yes. Now that can be made even better with the 3D versions of those fractals, right? Even harder to describe. And if you think it's too mathematical, too abstract, too inhumane, we can modify that to human voices, right? Because consider this, unless you are a professional voice actor, you'll not be able, to describe apart very similar voices, right? So consider instead you have fractals, you could instead have, I don't know, a pattern of voices, and then a sequence of pattern of voices, and then the sequence of correct, choices of voices gives you the parameters for a key, right? Anyway, so this is my proposal. This is tacit knowledge-based authentication. So since it's tacit, you are not able to transmit to your adversary, and this is how you defeat him, because you are not able, even if you wanted, you are not able to cooperate with your adversary, right? So this is what I'm aiming at. And yes, it is monetizable, right? Because you can just outsource this memory hash computation to an ally with more economy of scale than you, right? Because would you actually like to have your, device busy with intensive computation for even a few days or weeks? I don't think so, right? So you could instead opt to pay a few bucks to that service, online service, that you do that anonymously for you. You pay that anonymously, you get the result, and that can be even homomorphized, so the ally doesn't even know what they are calculating, right? So this is my proposal, and I hope you have liked it. Thank you already.